All right, so again, we're solving rational equations today, the easier ones. So, a couple of things that you need to remember when you are solving a rational equation. Look for a common denominator, because as we know, rational functions, they are fractions. And a lot of these are going to be a fraction plus another fraction, so of course, in order to add them or to subtract them, we need a common denominator. And I'm going to show you like a couple of ways to solve a rational equation. If you know of a different way, then by all means, you can use that. But the way I'm going to show you how to do it is you're going to multiply to get rid of the denominator. And of course, whenever you're solving an equation, you always want to check for extraneous solutions. Always, always. So, easiest way to demonstrate this is, of course, by example. So we'll start off, again, these are the easier ones today. We have x plus 6 over x minus 7 equals 0. This is a rational equation because we do have a fraction where we have a variable in the denominator. So to start off, we want to look for common denominators because we just can't add the x and the 6 and say this is x plus 6 over x minus 7 equals 0. We can't do that. Technically, this is x over 1. And the only way to add these two together is by getting a common denominator. Okay? So clearly, the common denominator between 1 and x minus 7 is x minus 7. Only this fraction is missing the x minus 7. So you can multiply x minus 7 to the top as well as to the bottom. So this turns into x times x minus 7 over x minus 7 plus 6 over x minus 7 equals 0. Well, what is this numerator right here means we can do what to it? We can distribute it. So, now that we have the common denominator, we can just add these two together, and yes, I am going to go ahead and distribute that x through. X times x is x times the negative 7 is, and because again, common denominator, I can write it as 1. Yep. Just like a regular old fraction, like if you were adding 1/2 and 3/4, the common denominator would be what? Well, 4. You multiply both of these by 2 to make it a 2 or 4. Same concept. Now, to actually go through the solving process, now that we've gotten our common denominator, we've multiplied, get rid of the denominator. How do you get rid of the denominator? Not FOIL. I heard someone say it. Multiply both sides by the denominator. Because that x minus 7 that's over here in the orange and this pink x minus 7 are going to what? Cancel out. No more denominator on that side. And over here, what's 0 times anything? How do I solve something like this? That's black magic. Well, you know, sometimes math is a little wonky, magical. But two numbers multiply to give you a positive 6, that add to give you a negative 7.
Negative 6, negative 1.
So after this point, we do what to these factors? And our solutions are 6 and 1.
This is an easy problem.
It is an easy problem, yes. Now you always want to make sure that you check for extraneous solutions. Remember, those are the ones that come out to be solutions, but then they don't work. To the what? The original for every x. So this is going to be 6 plus 6 over negative 1. Is that going to equal 0? Sure will. And if I plug in 1, so that equals 0?
Yes.
Yes. 6 over a negative 6 is a negative 1. 1 minus 1 is 0. So they both work. Questions on this one? Okay. Now, real quick, I don't want anyone to write this down, but I just want to show you guys something, okay? I'm going to take this same problem, and I'm going to do it another way, okay? This is one way. Here's another way to solve this problem. You have x plus 6 over x minus 7. Our common denominator was what again? X minus 7. So what I could have done instead was I could have multiplied every single term by x minus 7. And by doing that, I get rid of the denominator from jump. But again, you have to multiply by the common denominator. This would just turn into x times x minus 7. What do you think is happening to this pink x minus 7 and this red x minus 7? So then I'm just left with a 6. And then, of course, 0 times this is. And I'm back to that line that we had on the other page. Okay? So this also works. You can multiply every single term on the left side and the right side by that common denominator.
What if the term wasn't zero?
Say again?
What if it wasn't equal to zero?
If it wasn't equal to 0, say if it was like a 1 or something, 2, then you just distribute. So then it'd be 2x minus 14. Questions? Either way works. Here's our next example. Example 2. It's going to be 8. We're going to do 4 on this page. We'll do 4 on the other page. So all the easy ones on this page, all the harder ones on the other page. So we have 9x over x minus 2 equals 6. All right, hit me with it. Yes, get rid of the denominator. I don't have any extra terms over here, so I can just go straight into multiplying both sides by x minus 2. Again, no extra terms there, so I can just go straight into this. What happens to x minus 2's on the left side? So I'm just left with a. And now I can just solve this out nice and simple. Let's do it. Let's do it. You guys should have an answer in 3, 2, 1. What is it?
X equals negative 4.
I mean, like final answer. Like x equals negative 4. Because you subtract 6x from both sides. And then divide both sides by 3. And of course, you want to make sure you
don't have any extraneous solutions.
Exactly. What's 9 times a negative 4? And negative 4 minus 2? 2 negatives when you divide them make a?
Positive 6.
And that does equal a positive 6. Questions? These are the easy problems. The next one.
This one.
It's still an easy one. Okay? We do have 3 type of terms, and we do have 3 denominators, and they look different. This first denominator is x squared minus 6x plus 8. What do you think I could do to that?
Factor it.
Factor.
X minus 4.
It's going to be x what?
Minus 4.
And? Well, it looks just like this denominator has an x minus 2. This denominator has an x minus 4. What say you? What's the common denominator?
X minus 4.
Both of them. X minus 4 and x minus 2.
Multiply that one by x minus 4 and the other one by x minus 2.
So I'm hearing a couple of different things. I mean, all of them seem right, and they would take different paths to get to the answer. I heard someone say that I could take this middle term of 3x over x minus 2 and I can multiply the top and the bottom by x minus 4, which means that I would have to do what to this last fraction? Multiply by x minus 2 to get a common denominator. Yep. Or, what was the other way I heard?
multiply x minus 2 and x minus 4 to every single
Number on
Numerator.
top.
Numerator.
I don't.
term. Don't return that word. But yes, either way would still get you the answer. You can multiply every single term by the common denominator, or do it separately and do what we did before. Which way do you want to see it?
But it's easy. The easy short.
whichever you prefer.
Shortest way possible. Your preference.
My preference. Okay.
All of it.
Well, my preference is to multiply everything by the common denominator. That's just me though. If you are the other way, that's what the squiggly line is for, and I will show it the other way. So you write down which way you prefer. Now, the x minus 4 and the x minus 2 for this fraction cancels out. So I'm just left with a 4. No more denominator. The x minus 2 cancels out, but I still have that x minus 4 there, bless you. The x minus 4 cancels out here, but I'm still left with the x minus 2. No more denominators. This is nothing but a quadratic at this point. Okay? And I can solve it from there. Question?
Sure, I'll wait till.
Raise your hand if you want to see it the other way. Alright. So if I was to do it the other way, very quickly, I will multiply this one by x minus 4. This one by x minus 2. Then I would have then I can write as one denominator. Like one fraction on that side. And technically, since both sides will have the same denominator, I heard someone say it faintly, you can just get rid of it. And I will be right back to where I was.
That's a lot of letters.
All right. Can you guys solve this out for me? Solve that out?
What? -2 works. Because -2 is an answer. It works. I just plugged it in. I don't know what you're talking about. Because I just plugged in. Plug it in. It works. If it plugs it in and it works, then it's fine.
Still the same.
-2.
No, that was just what it
Go
is.
here.
How much is it with you?
Why is it -3?
Oh,
Why
I
would
did.
it not be -3?
You should have gotten these two solutions.
I got the words.
Alright? And when you check, when you plug in 4, okay? One thing you should notice is that this denominator right here is an x minus 4. So if you plug 4 in there, what happens?
0.
It's 0 in the denominator, which we can't have, which means that this is extraneous.
What did you do?
I took 4 and I looked at this circle blue part right here and saw that if I plug that in, I'm going to get 2 over 0. And you can't have that. At no point in time could you have 0 in any part of that rational equation. But the fact is that I'm going to be adding some number to an undefined number, which you can't do.
Oh, okay.
-2/3, it does work. Okay? If you're wondering, when you square a fraction, you square the top and the bottom. And go from there. Last example. I want you guys to to start this one off, and then I'll pick you up in about 2 minutes. We started there. So depending on how you did it, your common denominator was x times x plus 6, bless you.
Teachers, at this time, we do have some fast.
Alright, so I had the announcement going on while I was trying to explain this last problem, but you should have had negative 12 equals 2x plus the binomials that you have to multiply. After you get everything on the same side, you end up with x equals 0 and x equals negative 6. But when you go to check them, did either one of them work? No. So when this happens, that means there is no solution.
No solution.
Okay? That means there's no solution. And remember, when you're solving a rational equation, just like when you're solving any equation, you're looking to see where the graph crosses. Hold on real quick, guys. This is where you see where the graph is crossing the x-axis. So if there's no solution, what does that mean?
It never crosses.
It never crosses, which means there's an asymptote there. Okay? So those are all for the easy ones. We'll do the harder ones on